So review. Example, find the absolute max and min of f of x is equal to 3 times x squared minus 2x power 2/3 on interval 1, 4. And another one here. Find all values of x where the curve y equals x3 ln x2 has horizontal tangents. So to find the absolute max and min of this function, we need to find the critical numbers. So let's find f prime. The derivative of 3 times this is 2 times x2 minus 2x power negative 1/3 times the derivative of the inside, which is 2x minus 2. Okay. And if I simplify this, I could pull out a 2 on top. I get 4 times x minus 1. And this, since the exponent is negative, I could send on the bottom. And so I have x2 minus 2x power 1/3. And that is 4 times x minus 1. And if I factor the bottom, I will get x times x minus 2, each of them power 1/3. Okay, so this is f prime of x. Now, what are my critical numbers here? Can you tell me?
One and two.
Just 1 and 2?
Yeah.
I see another one.
There's 0, but
I
it's
found
not in the
0.
interval.
0 what?
It's not in the interval. 0.
Oh, you're right. Perfect. So 1 and 2, you're right. I forgot that it wasn't on the interval. Perfect. So the critical numbers in the interval. In 1, 4 are just 1 and 2. Okay, 1 obviously is anyways the end point. So let's find f of 1, f of 2, and f of 4. And I think the rest is pretty easy. So if you plug in 1 here, you get 1 minus 2 is negative 1, squared root of 1, 3. So I get 3 here. And if you plug in 2, you get 4, you get 0. And if you plug in 4, you get 16 minus 8 is 8. Cubic root of it is 2, 4, 12. Is that what you got? So I guess this is the maximum and this is the minimum. That's it.
So you found the 2 from the denominator, right?
Yeah, exactly. This is a place where the function is not differentiable.
Okay.
Okay, so obviously you would have a graph. I don't know what it looks like, but one thing that's for sure, between 1 and 4, 1, 2, 3, 4. At 1, it's 3. Let's say at 4, it's 12. And at 2, it's 0. So it looks like this.
Wait, so should f of 1 be -3?
Should it be? F of 1. So 1 minus 2 is -1. And -1 power 2 becomes 1. And then 1 cubic root becomes 1, stays 1. That's 3.
Okay.
Okay, so this is power 2 cube root. Power root, okay? So as you see at 2, you have a place where the function is not differentiable. Okay, any questions? Okay, let's do the second question. Find all values of x for which the function has the horizontal tangent. So basically when the derivative is 0. Okay, so y is equal. So I'm going to simplify things a bit by bringing the 2 in front. 2x cubed ln x, that's y. Y prime is, so let's do the product rule, 6x2 ln x plus 2x cubed times 1 over x. And so y prime is 6x2 ln x plus 2x2. And so y prime, if I pull out a 2x2 times 3 ln x plus 1. Okay, so y prime equals 0 when two things, either x is 0 or 3 ln x plus 1 equals 0, which means that x is e to the power of -1/3. There you go. There are 2 values for which the function has a horizontal tangent.
Wait, sir, why is it 2x power 3 when it was just x power 3?
2, sorry?
Like here, before it was x power 3 at the beginning.
X,
and
y,
then
what is x, y3?
x power 3
Yeah,
ln x power 2.
yeah.
And then what did you
This?
do here? Yeah.
This. I just put the power inside the ln, I could bring it in front.
Oh, okay.
One of the properties of longs. Any questions? So find the 75th derivative of f of x is equal to x over 3 minus x. So let's start finding derivatives here. First derivative, so we'll do the quotient rule, derivative of top, which is 1 times bottom, minus the top times the derivative of the bottom, which is minus 1, divided by the bottom squared. Okay, and that is, if you simplify, you get 3 minus x plus x is just 3 over 3 minus x squared. Second derivative. So the 3 stays. And then this is 3 minus x to the minus 2. And so that is 2 times 3 minus x to the negative 3. Third derivative, 3 times 2, and then to the minus 3, so it will be times 3 minus 4. And I keep going like this. Third derivative, fourth derivative. Three, 2 times 3 times 4 over 3x minus 5. Okay, so basically, this is 3 times, so this is 4 factorial, right? 2 times 3 times 4 is 4 factorial. We've talked about this before. Over 3 minus x. Oh, there's no minus here, sorry. There's no minus here. Power 5. Okay, can you give me a general formula here? The nth derivative of f. Can you tell me what that's going to be based on this pattern here that I recognize? Okay, so here will be 3 times, this will be 3 factorial over 3 minus x power 4. This will be 3 times 2, which is just 2 factorial, 3 minus x power 3, and so on. And this is 3, 1 factorial. So 1 factorial, 2 factorial, 3 factorial, 4 factorial. If you go to n, what will you get? 4, 4, n. Go ahead.
3 times n factorial.
Perfect. Over
3 minus x
power
n plus
n what?
n plus 1.
Very good. Okay, so this is the general rule for the nth derivative of this function. And we're looking for the 7/5 derivative. Okay, so it doesn't matter which number I put as an n now. So 3 times 75 factorial over 3 minus x power of 75 plus 1, which is 76, and that's my answer.